Assalamu alaikum class. Today we are going to focus on how to calculate time when they are missing, particularly in the context of time value of money. As you know, generally you are asked to find out either present value or future value with given interest rates and time period. However, in some cases, you might have both the present value as well as the future value, but time period is not provided. So what we do in those situations? We will go through a method that uses present value, future value, and the interest rate to find out or to figure out the missing time period. So let's start with some examples from the book Fundamentals of Financial Management by Brigham Houston, Chapter 5, Time Value of Money. And we will cover problem number 5 4, 5, and 13 in this lecture. So let's start with Excel sheet. So here you can see that we have, if you deposit money today, today means right now, or they are talking about present value in an account that pays 6.5 interest rate, annual interest rate. So I or interest rate is given. How long will it take to double your money? Double your money means the future value would be double. Whatever you consider, whatever you assume, present value, because in this problem, present value is not given. So whatever you consider present value, it will be doubled in case of future value. For example, I assume that present value is $100. So what will be the future value? Double means $200. If I assume the present value is $1,000, so future value would be double, that is $2,000. Interest rate is given, and how long will it take? So time period is not given, and this is the scenario, or this is the case when we have single values, a single compounding. So let's start. Now n would be inverse of future value divided by present value. So I assume future value 2000 and present value 1000, and whole divided by inverse of 1 plus I. 1 is from the formula, I is interest rate 0.065. So here you can see in the next step, n inverse of, when we divide 2000 by 1000, so answer would be 2, and then inverse of 1.065. So in the next step, when we take inverse of 2 on your calculators, so use your calculators, take inverse of 2, the answer would be 0.69314, and this divide by inverse of 1.065. So when we take inverse of 1.065 on calculators, so answer is 0.06297. So here n will be 11, 11.007 years. So we can also do it via built-in formulas in Excel. So here we go, financial, and this is number of periods, time period. So we take NPR, rate is 0.065. Uh, Present value is 1000. So we take it 1000. Future value, present value is 1000. Future value is 2000. So The answer would be, you can see 11.00 years, 007 years, or simply you can see, say, 11 years. So time period is 11 years. This means that if you deposit $1,000 right now at the rate of 6.5% rate of interest, then it will be doubled. That is, it will be converted into $2,000 in 11 years. So next example is 5.5 here. Time to reach the financial goal. You have $42,180 in a brokerage account. You have means this is your present value. Right now you have this amount. You plan to deposit an additional 5,000 at the end of every future year. Every future year means every year. So this 5,000 represent PMT, payment, because payment has to be submitted every year or every time period. So this 5,000 represents PMT until your accounts total $250,000. So this $250,000 is your future value, and you expect to earn 12% annual interest rate. So annual interest rate is 12%. How many years? Now time period is required, time period is not given. So here it is the formula. We use this formula when we have annuity. Um, we have payment, we have annuity, and this we use this formula when the amount is, or the time value involves simple uh, values, means simple present value or simple future value. So here, as we have PMT, so this concept belongs to annuity. So we are going to solve it. N represent time value, and we take log of 1 plus I mean interest rate, which is 0.12. On the other side, we take log of future value, which is 500, 2000 and $250,000 plus PMT. PMT is 5,000, but this PMT is divided by rate of interest, which is I, which is 0.12. Then we have present value, which is present value here. It is given 42,180. So 42,180.53 and plus PMT, which is 5,000, but this PMT is divided by rate of interest, which is 0.12. So when we solve it further, we take, we have N, and when we take log of 1.2 on your calculator, then log of 1.12 is 0.049218. So this is the log of 1.12. On the other side, we have log, but first of all, we will have to solve uh, this equation. So I'm copying it here. So here, this one. So when we solve this, means the 5,000 is dividing by interest rate plus future value. So we got $291,000, and similarly this one. On the next step here, we have log. Uh, there's no sign of equality. We take log of what? First of all, we have to divide 291,666.667 by 83 847.19667. So here, in the next step, we take log of 3.4. So what we can do in this here I have taken this amount log of 1.12 I calculators, and I'm going to show you how to calculate log with the help of Excel sheet. So here I have formulas, functions, and all functions, and then L log. So this one is log. Okay, so here log, and the amount is this one. Okay, so no, I'm taking again. We have functions and more functions and all and log. So here it is log, and I'm taking log of this amount. So log of this amount is 0.541. In the next step and the last step, n n will be, now we already have 0.0541398, and we take this because on the other side of equation this is multiplying with n. So when we take in the right side is going to be divided 0.049218. So n would be, you can see here I'm showing you step by step calculation. So n is 11 years. This is a step by step calculation. But how we will do it on with the help of built-in formulas, you can see formulas, financial, and what we are going to find out, n per period. So this is n. Rate of interest is 12%, that is 0.12. Now we have payment, PMT. So we are going to deposit additional. Why I use the sign minus? Because I'm going to deposit it. When you deposit some amount, that this means that the amount will be negative. So present value, then again it is negative sign with negative sign, 53, and what you will get in the future, 250. That's why it is positive, because you are getting it and you are paying it right now. So here you can see the answer is 11. So whether you calculate manually, because in exams you will be asked to calculate it manually. So here it is the complete procedure. But practically, when you are doing your office work or when you are doing your business or job, you can do it on the Excel sheet. There's no need to do it manually. So here, this is problem number 5 dash 5. The last problem for today's lecture is 5 dash 13. Again, time for a lump sum to double. How long will it take 200 to double? 200 means 200 is your present value. Double means it will be 400. So 400 is your future value. If it earns the following interest rate, so interest rates are given. I'm going to calculate it first of all manually, then we will do it via built-in formulas. And what we are going to find out, n. So we will take inverse of future value divided by present value. So present value is given, which is 200. Future value means doubling the amount. So it will be 400 divided by 200. And then inverse of 1 plus I. In the case 1, interest rate is 7%, to 0.07. So when we take inverse, um, this is 1 plus I. So 1 plus I. Okay. On the other step, when you divide 400 by 200, so you get 2, and this would be 1.07. So when you take inverse on your calculators, inverse of 2 is 0.6933147. And this is going to be divided by inverse of 1.07. Inverse of 1.07 is 0.06765. So in the last step, when we divide 0.6931 by 0.0677, the answer is 10.23, and the data is compounding once a year, so answer is 10 years. And we can also confirm it via built-in formula on Excel sheet. So you can see we are finding time period. So N per rate of interest is in part A, it is 0.07. Present value is 200. Future value is 400. And this is simple compounding. So there's no PMT. And right now you are investing, or so one value should be negative. So here you can see the answer is almost same because of rounding off. This is 10.23 and this is 10.24, because I have just taken 4 digits after a point. In built-in formula, they take almost all digits. So here it is the answer of part A. So let's move toward part B. In part B, we are going to repeat almost same problem, but the only rate of interest will be changed. So I'm repeating, I'm taking this, I'm copying this, because just rate of interest from you can say 7% to 10%. In part B, it is 10%, so it is this much. So in the next step, it would be 1.1. And when we take inverse of 1.1, the answer is uh, 0.09531. And I'm taking inverse in calculators. So when you divide this amount by 0.0953, the answer is 7.27 years. We can confirm it or we can check it with the built-in formula. So here we go. It is financials, then time period. This is N. Rate of interest is now 0.110%. Present value is same, that is 200. Future value is same, that is 400. And you can see the answer is same in both cases. 100% same answer is there. So in part C, I'm again copying this one, because we are going to change only rate of interest. In C part, the rate of interest is 18%. So this would be 1.018. So here we have 1.018. And when we take inverse of 1.18, so the inverse, the answer will be 0.16551. So when we divide 0.69 by 0.1655, so the answer will be 4.18 years. So we can check it with the help of built-in formulas. Again, we have financial, this is time period, and the rate of interest is 18%. Present value is same, that is 200. Future value is same, that is 400. And you can see the answer. The answer is almost similar. In the last step, in the last part, we have part D. The rate of interest is 100%. So here, 100% means when we divide 100 by 100, so answer is 1. So 100% means 1. Here we have inverse of 2. So what is the inverse of 2? Again, it would be same. That is 0.693693 It is same as this amount. So here you can see 0.6931 is divided by now 0.6931. That is with the same amount. So just 1 year. If the interest rate is 100%, the present value will be converted into future value, that is to double it in just 1 year time. So we can check it via built-in formula. We may be right, may be wrong. So let's check it. Here we have formula, there financial, and we are going to find out time period. In time period, rate of interest is 100%, or present value is same 200, future value is same 400. So what would be the answer? That is, you can see 1 year. So answer is 1 year. So in this lecture, we have learned that how to calculate missing n, or time period, if present value or future value is given, and interest rate is also given. But one thing we have to know, or we will be very careful about this, that here this formula is useful if you are using simple compounding, and this formula is useful when we have annuities, either present value or future value concept, but for this formula is useful for annuities. So that's it from this lecture. Take care, class.